Good afternoon, class. Today, we want to discuss about sampling techniques. And when we look at these techniques, they are going to give us a sample at the end. A sample, by definition, we said, it is that group that will represent the whole population. We went through the various advantages as to why one would prefer sampling other than dealing with the whole population, what we call the complete enumeration or the census. Out of those advantages, now that you have already made a decision, your study will be conducted based on a small group of the elements selected from the population known as the sample. How do we come up with that sample size? And these are the techniques which will divide into two areas, namely those which are based on certainty and those where we may be having a problem in defining how will be the outcome. These are categorized as under the probability sampling methods. And then if we are sure of the outcome, or we can be able to tell what we'd expect at the end of the day, that there's no language or probability involved, there's no that doubt, then we talk about the non-probability sampling techniques. So to distinguish between these two, for the sampling techniques, this is where we have got no direction on what is actually going to be the outcome. So we have got that element, we are not sure. And when we talk of surety is not actually guaranteed, then we have to use probability theory. We assign chances to the outcomes, or rather the events taking place, so that at the end of the day, we can have that particular element, we can have that particular maybe individual being part of our sample that will now base our evaluation, will base our judgment, will base our what we call the analysis upon. And therefore, to come up with this, that element of a probability value may be attached to this particular technique. As we look at this, we'll have the following methods, which falls under sampling techniques method. And we'll discuss number one, the random sampling technique, also abbreviated as RSS or RST. Sometimes here we'll look at a small group where the chance is actually the same for whichever element to be involved in the sample. Then we look at the systematic sampling method, the stratified sampling method. We also have the cluster sampling method, and more importantly, I would want us to see how we can distinguish between the stratified method and the cluster method. Cluster sampling method, also known as the block sampling method. Then we have the multi-stage sampling method, sometimes referred to as multi kind of a purpose method in the correction of the data, where you deal with as many stages as possible until you reach to a desired level, that this is the sample size, and so I can conduct my study based on this. The non-probability sampling techniques do include the following. We have the propulsive sampling method. We also have the quarter sampling method, the convenience sampling method, the most important methods that we'll study as far as the non-probability techniques in sampling involved. Let's start with the first method, And this is the simplest method of drawing elements from a given population to be part of your sample. Here comes a population. You just draw elements at random, and therefore we call it a probability sampling method, because you don't know what will be the outcome. However, each and every element in this particular population is going to have an equal chance of it being included to be part of the sample. That is, there is a equally likely chances given to all the elements constituting the population, and therefore any element can be chosen to be part of that particular sample. It doesn't actually give priority to any element. All the elements in the population are going to have equal chance of being involved in the sample. For example, if we have a class of, let's say, 40 students, and an element is to be drawn at random using the random sampling technique, then it would mean each and every student in that class will have the equal chance of one student out of the total number of the student to be included in the sample. This is what we call a classical method of assigning probabilities to some of the events taking place, and therefore when we are assigning the same chance to all the elements in a given population to be chosen, then we say such events are equally likely, okay? And because each and every element is going to follow the same probability value of being included to be part of the sample, and that we are doing it at random, then we constitute what we call a random sampling method, but in just but a simple way. Take an element, divide by whatever are the total number of elements in the population, and that gives you the probability value to be assigned to each and every element when it is being chosen to be part of the sample. Okay. A good example of such techniques, or rather the simple random sampling technique, it is, for example, what happens in the Rotary games. We have a raffle ticket that we were selling. As many customers came in to buy those particular tickets, when they are all put in a particular basket, reshuffled, and then one person is put on a bright eye, you're told, have your hand in the basket and pull a particular ticket, then we mean, because you're not favoring any ticket in the basket, every other ticket would have a chance of one out of how many there were in the basket to be included in the sample or to be selected. That is a good example of what we call a simple random sampling method. So you'll continuously do the same. Once you have selected an element, okay, you may put it aside, you pick another using the same procedure until you reach to a desired sample size. For example, you may be going back to the same class. Let us assume you're doing it without replacement. So the first chosen student had a chance of 1 out of 40. Then if one is out of the class, then it would mean selecting another, you'd have a chance of 1 out of 39 being the total number of students remaining in the class. Then if you still continuously select your elements without replacement, then the next student to be selected will have a chance of 1 out of 38. Remember, you are not replacing back the students to the class. And if, for example, you want to come up with a sample size of 5 students, maybe you want them to participate in a certain contest for the school or for the class, then you'll finally have reached to a desired level, and then you say, these elements were actually reached to, or this particular group as my sample was reached to using what we are calling the simple random sampling method. You may also wish to select your elements, let's say from that basket with replacement. What happens under the case of with replacement, you're selecting an element, taking it back to the same basket, picking another or even the same until again you reach to a desired amount of elements that you want to constitute to be your sample size. So that is how we do correction of the, or rather the selection of elements from a particular population to give you whatever the size of the sample you want to come up with as you, for example, carry out your research work. What are some of the advantages and the disadvantages involved when it comes to a simple random sampling method? Number one, it is scientific in that we are not actually favoring any element. Randomization eliminates what we call personal biases. Maybe somebody loves you so much, so he or she wants to be the one to select you, and so you be included to be part of the sample. Since you're doing it at random, there's no such cases that I know you better, and so I must include you to be part of the sample. The personal judgment is actually eliminated, and so this one helps to minimize what we call the errors which could be associated with the sample, and out of that you now make good inference about the population based on that particular sample size. Another very important advantage is that there's no such high level of education that will be required for you to select the elements from the population. Neither do you require to have known better about the characteristics depicted by the elements constituting your population. Yeah, there's not that prior information that I must know you better to be part of my sample elements. No, anybody can actually pick an element, especially if you are knowledgeable in the area of why are you picking these elements, what is that study that you're conducting, and know such knowledge which will be required for you to have, for example, known all the elements in the population. And that helps you to minimize the time which you require now to devote into your other areas as far as your research is concerned. You want to correct the data as within a short period of time as much as possible, carry out your investigation, come back and make the conclusion about the population. Yeah, given the chance, can you pull a few elements from this population, come up with a size of, let's say, 5, conduct your survey and give us the results, which you can use now to make the conclusion. Since that knowledge is not required for you to have known the features about the population before, all just a retro information is required, then it helps us to minimize the time which we'll use now for our research work. And that is a good benefit that we can reap from the simple random sampling method. On the accuracy and the minimization of the errors, it takes us back to advantage number 1, where we are talking about elimination of our personal biases. If we are doing it at random, then it helps us to maintain a higher level of accuracy. And when accuracy is actually achieved, then it means results obtained from the study based on those elements where no personal biases or no personal inferences were involved, then we'll be able to attain reliable results, which we can actually now say our conclusions are based on this. And as a result of that, we can actually say they are trusted results. Another very important thing, you see you're picking elements at random. And as a result of that, would expect if you're minimizing the personal biases, will have a sample size reach to the elements now chosen to be part of your sample as a good representative of the population. Remember, we are correcting this data from that sample now already chosen from the population, such later on will come back after our survey we make the conclusion about the whole population. So we want to ensure that whatever is the data we have collected, we have now done our survey, our conclusions are like this, they'll be representative of that particular population. So simple random sampling method, because of the randomization, yeah, it helps us to achieve a sample that is actually going to be a representative of that particular population. Universe represents the population. Another very important thing is that there is no such complications involved when you're drawing the elements from the population. Very simple. Get into the basket, pull one particular ball, get into the class. This is the list, call any name. You see, very, very simple, and it is actually going to apply in as many areas as possible. It is practical in nature. And the doubts by other people, for example, may not be there. And as a result of all this, remember we have said we need to know a lot of information to be maybe associated with the population where you are getting the sample. So because of that, yeah, you save time. Again, any person, especially if you have maybe some information in the field of statistics, you can use such resource to help you come up with a sample. So there's no way to which you're going to spend a lot of money in trying to come up with the elements which will give you the sample size. In return, you actually conduct a survey. And these are some of the advantages that we really talked about. Why did I choose to go for sampling and maybe not for the census? Some of the problems associated with this method or technique would include what? It requires you to have a population that is complete. For us to say that the results were reliable in that we maintained accuracy or we minimize the personal biases, let there be as many elements constituting the population as possible. Make sure that that particular population is complete. So that when you're pulling the names, then we will not actually say, since I wasn't there, that's why I wasn't chosen. Let there be the complete universe to which you are dealing with as you get your sample elements. Another very important disadvantage we cannot forget, and if we are to go back to our previous disadvantage, do we have the information about all the elements constituting the population? If that information is not available, then it will affect our advantage of the time saving, in that you require to first of all get the information about all the elements from the population, and that now contradicts our various, or rather the previous advantages that we have talked about. So if that list is not available, it may be consuming a lot, or it will actually now lead to a case where we will doubt whether our results were accurate or to be relied upon. Another very important point, assuming your population elements are not put together, like I have the, let's say, our survey students to be pulled together from the various campuses, and such campuses are far away from each other. By the time we are now saying that we have had a whole list of the population, a lot of time will be involved. And you see now that becomes a disadvantage as far as the simple random sampling is concerned. Earlier alone we said this. The size of the sample depends on what? The population size. And they go hand in hand. There's that particular proportion element. If the size of the population is large, so should be a sample size. Whenever you're dealing with a sample drawn from the population, that sample should be a true representative of the population. So if you have chosen a small group to be part of your sample, yeah, but that sample happens not to be a true representative of the population, then we'll come and make conclusions, but those conclusions may be misleading. So important to note, the sample size should always be determined by your population size. So if you choose a small sample, but the population was actually very large, then your results may be misleading in that you'll be making long conclusions about that particular population. It's a disadvantage in that if you're not careful in remembering, yeah, that if your size was large, you needed to come up with a large sample size, then there comes a misleading result, which will now make the conclusions made about the population not to be correct also. Another disadvantage, for us to say our results were accurate and reliable, then the degree to which we involve in our correction of the information, yeah, should actually be taken care of, but it laws back to what? What were the elements chosen from that particular population? What was our size of the sample? Did we come up with a size that is actually going to be a true representative of the population? So for the given degree of accuracy, then you have to increase the sample size. But maybe you go back and you say, I want to minimize the amount of cost incurred in my sampling process. So if you compromise on such particular aspect of accuracy, in the name of you want to save on some amount, then you end up having misleading elements. So just say our last two points here are actually like an emphasis that in case you are to have a good representative of the population, then let it be that whatever are the elements you have chosen, that size goes hand in hand with the population size, so that the degree of accuracy is maintained, and then later on, you are able to make good conclusions about the population based on that particular sample. Okay,